rational root theorem is just an extension of our division theorem, in that the numbers that we pick, I was talking about how the numbers we pick are going to be a product of the 2 and the 3. Okay, now I guess that's a simplification of the numbers that we can pick, and you don't necessarily get all the numbers that are possible. What my rational root theorem does tell me, however, is that the factors of the last term dividing over the factors of the first term, a combination of them will give me the solution that I want. So I guess if we go back to our previous example just a bit higher, and we had x cubed. So if we talk about this example here, what I'm saying is the factors of 6 over the factors of 1 could be my solution. So I get plus or minus 6, plus or minus 3, plus or minus 2, plus or minus 1, all over plus or minus 1. Okay, so they're the possible values that we could have. And obviously there's a whole lot of them there. So invariably and typically we just try the integer values, okay, which is why we just spoke about 1, 2, and 3 and plus or minus, okay. It is sometimes and often you will be instructed that we might need to use the rational root theorem, which means then my solutions or my numbers that I'm going to guess, okay, are going to be plus or minus 3 over plus or minus 2. So 1 and 3 are the factors of 3. 1 and 2 are the factors of 2. So if you have a look at the combinations here, I've got obviously 1 and 3 could be the solutions, okay? But also 1 over 2, 3 over 2, all right? So if I just try at random, say if I just try p of a half, I get 2 times a half cubed minus a half squared minus a half minus 3. That's equal to 2 on 8 minus a quarter minus a half minus 3. So clearly with minus 3 there are only fractions there. So that's not equal to 0. Okay, so a half isn't going to work. So I'm thinking I've got to get bigger numbers here. I've got to try and get these numbers here to be bigger than 1 so I can get up towards -3. So, right, so I'm going to try 3 on 2. So if I try 3 on 2, I end up with 2 times 3 on 2 cubed minus 3 on 2 squared minus 3 on 2 minus 3, which is, what's that, 27 on 8. So 2 times 27 on 8 minus 9 on 4 minus 3 on 2 minus 3. So they cancel. So that's a 27. Let's make everything on 4. 27 on 4 minus 9 on 4 minus 6 on 4 minus 12 on 4. So that's going to give me 27 minus 27 over 4, which is equal to 0. So P of 3 on 2 is a solution, okay? And what that means is that consider the general form. It said negative b on a, okay, is equal to 0. That's for ax plus b. So in our case, therefore, negative b is equal to 3, a is equal to 2. So our factor is 2x minus 3, okay? So really all we're doing is the numerator, we change the sign on that, and then the denominator is the x coefficient, all right? So that means 2x minus 3 is a solution. So let's have a look at having a go at our division with our coefficient not being 1 at the front, all right? So my coefficients, I've got 2, -1, -1, -3. Now I'm dividing by 2x minus 3 here. So that's a plus 3 out there. The coefficient of x is not 1, it's 2, which means I'm going to divide by 2 at some stage. Okay? So let's go through the process. Bring the 2 down. 2 divided by 2 is 1. 3 times 1 is 3. Add them together. Negative 1 plus 3 is 2. 2 divided by 2 is 1. Times by 3 is 3. Add them together. It's nice numbers, aren't they? 2 divided by 2 is 1. 2 divided by 2 is 1. 3 times 1 is 3. Add them together, I get 0. Well, that's a good sign. So there's my remainder. So there's my coefficients. So my factors, 2x minus 3, which I started with. My coefficients here. So I've got x squared plus x plus 1. Now, since these are all positive, I'm pretty confident that they're not going to have any factors or any, so I can't factorize that. So I'm going to leave my answer as that. All right. So 2 parts to this one. If we have, you'll nearly be told to use the rational root theorem, which just means you need to use a combination of these numbers on top of each other. Okay. You certainly won't use them by choice. All right. Always try the integer values. 99 times out of 100 is going to be a 1, 2, or a 3, plus or minus, all right? If by chance you're told to use rational root, you're going to have to work with a fraction, all right? Once you work with that fraction, that's probably about the only time you're going to have to use this synthetic version, just slightly different. Change the sign of the number at the front, and we've got that divide by 2 factor that we need to consider, all right? Off you go.